Today what we're going to be doing is reviewing how to simplify radicals and using that simplification with Pythagorean Theorem. Now typically I kind of do this all at once, like when we go over Pythagorean Theorem, but because I wasn't here, I wanted to make sure that we know how to simplify radicals because we're going to be using this a lot from here on out. So I did make just a list of perfect squares for you because if you remember, simplifying radicals, you're always looking for a factor that is a perfect square. Okay, these are ones that are used the most. You probably recognize most of them. For some people, like 16, 17, 18, 19 get a little hairy. They forget those, but there is that list for you just to refer back to if you need to. In terms of simplifying radicals, if we're going to simplify a radical, we want to factor out what's underneath the radical sign into a perfect square and a non-perfect square. And then we bring the root of the perfect square outside. So for instance, the square root of 200, I can rewrite that as the square root of 100 times the square root of 2. The square root of 100 is a perfect square. I know that the square root of 100 is 10. The square root of 2, that's as simplified as it can be, so I leave that as radical 2. This is our goal. We want it, instead of writing it as the square root of 200, to write it as 10 radical 2. Okay, so now let's look at the square root of 63. Square root of 63. 63 I know is 9 times 7, and I know 9 is a perfect square. 7 is as simplified as it can be. So this would be the square root of 9 times the square root of 7. The square root of 9 is 3. And then we leave the square root of 7 as the square root of 7. Now, as you start remembering this or practicing this more, I don't really need you to write this step if you don't want to. If you can do 9 times 7 in your head and you know the square root of 9 is 3 and you just want to write that as 3 radical 7, I'm happy with that. All right, 2 more examples. Square root of 20. Okay, so that's 5 times 4. So I have the square root of 4 times the square root of 5. The square root of 4 is 2. So I have 2 radical 5. Now 48, I'm going to do 2 different ways because I want to show you what happens when you don't pick the biggest perfect square. So a lot of times what people do is they'll see 48 is 6 times 8. All right, so they'll recognize neither one of those are perfect squares, but they recognize 8 is going to be the square root of 4 times the square root of 2. Well, we know the square root of 4 is 2, and then we still have the square root of 6 times the square root of 2 left, which we know is 6 times 2 is 12. And they think that they're done. Well, you're not, because the square root of 12 can be broken down further, because 12 is the square root of 4 times the square root of 3. And again, we know the square root of 4 is 2, so I'd have 2 times 2 on the outside, and underneath my radical, I'd have a 3. So it ends up becoming 4 radical 3. So if you don't pick the biggest perfect square, you're going to have to keep going a little ways, like the way I did here. But keep in mind, 48 is also the square root of 16 times the square root of 3. The square root of 16 is 4, and then I still have my radical 3. All right, so sometimes if you don't pick the largest perfect square, you might have some extra work to do. So try to think through those. And honestly, the more we do them, the more you're probably going to recognize them. 48 is one that catches people off guard all the time. All right, so we are going to now use Pythagorean Theorem with our right triangles, and I want to leave our answer in simplest radical form. All right, so we know that a squared plus b squared equals c squared is our Pythagorean Theorem, right? In our case here, the x is my c, right? That's my hypotenuse. So I have 12 squared plus 5 squared equals c squared. That's 144 plus 25 equals c squared. I add that together, I have 169 equals c squared, and I want to find the square root of 169. Now this one's nice because it's a perfect square, right? So the square root of 169 is 13, so I can just write my answer is 13. Okay, so that is a simplified square root. If it's a perfect square, then you just write what your answer is and you don't have a radical left. Let's look at the next one. So I have x squared plus 7 squared equals 9 squared. So keep in mind 9 is my c value, right? That's my hypotenuse. So I have x squared plus 49 equals 81. I need to subtract 49 from both sides. If I subtract 49 from both sides, I'm going to get x squared equals 32. So now I need to take the square root of both sides. So x is going to equal, I need to break this down. So this is going to be 16 times 2. The square root of 16 is 4. So my answer here is 4 radical 2. And that's exactly how I want you to leave your answer. Okay, our last problem here. Again, I want to identify C for my hypotenuse. So I have 6 squared plus x squared equals 8 squared. So that's 36 plus x squared equals 64. Subtract 36 from both sides, and I get 28. Take the square root of both sides, so I have x equals, this would be radical 4 times radical 7. The square root of 4 is 2, so my answer here is 2 radical 7. So what you're going to be doing is, in Delta Math, I have practice for you in terms of Pythagorean Theorem and simplifying and leaving your answers in terms of radicals. Again, this is going to be super important for us next week. That's why I want to spend time today going over that.